Hi everybody. We're going to do our nice movie for our review problem. And I'm going to do problems 1 and 2 on the R Commander and then do problems 3 and 4 using something else because we have to write stuff out. Okay, so let's take a look at the first one. And we are going to look at this, and it is, we get to see one of my friends from Women and Bicycles sent me an email. A psychiatrist wants to know whether the level of pathology Y, so that's our dependent, of psychotic patients 6 months after treatment can be predicted with reasonable accuracy from knowledge of pre-treatment symptom ratings of thinking disturbance X1 and hostile suspiciousness X2. The data are in thinking.txt. Find the least squares regression equation. So that's our multiple linear regression. So let's go to data. See, the Mac is going to be nice and uncooperative today. Import data. Nice and uncooperative. Here it goes. Come on. All my computers have been uncooperative today. And let's call it thinking. Let's just call it think. That's easier. Think. And it's actually here. Say thinking. Tech. Okay, let's just look at the data set. There's 12 values. There's your Y, there's your X1 and X2. This is just from another textbook. They didn't really say what kind of scale these were measured on. So we need to go to statistics, fit model, linear regression. So our response variable was Y. Our explanatory variables are both X1 and X2, so hit Control on those and hit OK. Yeah, it already exists. I don't care. There you have it. Okay. So, I'm just going to be writing on here. So I'm going to use the hashtag symbol. So that's like the comment. So I'm going to have Y is equal to minus 33.9 plus 40.08 X1 minus 8.843 X2. Okay, that's my least squares regression equation. Okay, my second is to test for the overall fit of the model, and you know how crazed I've been recently about getting the, no pun intended, about having the hypothesis test. So we're going to have HO, and that's going to be, well, I can't have betas on this one. It's going to be beta 1 equal to beta 2. So how did I know it was just going to be beta 1 and beta 2? Because I only had two x variables, x1 and x2, versus not all b sub I are equal. Okay, the p-value, which everybody better get, is of course equal to where it says p-value 0.077. And here, since I didn't say explicitly, let's just assume it's going to be, oh, I didn't actually say explicitly, and it is 0.05. Our step 3 is, of course, goodness me, if p is less than alpha, in this case 0.05, Then we reject HO. And we will fail to reject. Very dramatic. Reject H. Oops. HO. So, nothing too interesting here. Okay. All right. So let's assume for a second that this model was decent and provided information. And I wanted to see, okay, I select a person at random, a patient at random, and that person had a disturbance score of 2.8 and a rating of 7 on the hostile suspiciousness. What would we expect his or her level of pathology to be? So then we just plug the values in. So I have minus 33.9 plus 40.08 times 2.8, oops, 2.8 minus 8.843 times 7 and hit submit. And the score would be 16.423. Okay, so that's all there is to it. And then for the stepwise procedure, you're going to go to Models and scroll down to where it says Stepwise Model Selection. Okay? Take the default of the backwards forwards and take the default of the criterion, the BIC criterion, and click OK, and just let it run and see if it comes up with a better model. And you'll see as it went through, it does come up with a better model. The better model actually is just the intercept and the x1. So the best model based on this would then be y is equal to minus 92.75 plus 40.78 x1, which is kind of interesting. Okay. All right, that pretty much kills problem 1. Then let's see, problem 2. Good times. All right, so we're going to grow some poplar trees. So we're going to use a randomized block design. We're going to have 4 treatments and 2 blocks. The treatments are a control. So when we have a control, essentially you're not doing anything. You're leaving them alone. No treatment. Okay? So the lack of treatment is in and of itself a treatment. Fertilizer, irrigation, and the 4th one is a combination of fertilizer and irrigation. So then you have 2 block types, 2 blocks which represent soil types, moist and dry. The data are in poplar.txt. Test a claim of equal treatment means, let alpha equal 0.5. Test a claim of equal block means, let alpha 0.5. And I don't know if I mentioned this in class. I probably did. Whenever you do the test on both treatment and blocks, you always want to have the same alpha level. Okay, so let's put this baby together. So let me close out the data set over here. So you're going to have data, import data, and let's just call it poplar. And go into Dropbox, poplar.tech. What do you mean it doesn't exist? Okay, let's go app 1. Let's try that. There, okay. Cool. All right, and let's look at the data set. There it is. So you've got response, you've got your treatments, you've got your blocks. All right? So you've got no treatment, fertilizer, irrigation, and C standing for combination, moist and dry. Okay. So as we saw this week, randomized block was a little weird. So go into statistics, fit model, linear model. So you have to set up a formula first to make this go. You're going to double click on response. You want response, it's a numeric value. You want that to be on the left hand side of the formula. So double click on that. So you see how you filled in your left hand side? And then you have the tilde. And see how the cursor popped over to the right hand side? That's great. You want to have your randomized block to be a function of your treatment and your block. So then double click on treatment, then the plus sign, then double click on block. Okay? Then click OK. And that sets up a model, but it doesn't set up an ANOVA model. So you have to go back in and go into models, go into hypothesis tests, and go into ANOVA table. Make sure it's set to type 2 and click OK. And there you have it. Oh, this is really boring today. And you're going to test on both kinds of treatments. So let's do our hypothesis test. So you're going to have your HO, and I'm just going to use M instead of mu. So I'm going to have mu1 is equal to mu2 is equal to mu3 is equal to mu4. That's for my 4 treatments versus not all mu sub I are equal. And you can't do a whatchamacallit, the test for the difference, the Tukey test on here. Okay, then the p-value, you're going to test on the PR greater than F that's associated with the treatments. In this particular case, it is equal to 0.5977. Then if, oh, sorry, I went wild. If P is less than 0.05, then we reject HO. And we fail to reject. Okay, so there's essentially no difference between the treatment means, which kind of surprised me when I looked at the original data. Let me show you. I thought it would the combination would make it pop up because it's so strikingly different, but hey, obviously it didn't. Then similarly for the blocks, now I knew we weren't going to on them. In case you were wondering, that's, how did I know? Oops, B1. That's just from doing it a million times. Versus, I can't always tell. Sometimes I can. Not all B sub I are equal. And then the p-value is 0.6340. if you fill that in, make sure you fill that in, and of course, fail to reject. Okay, make sure you're filling that in on the test tomorrow. All right. Okay, so you can do that all right? Good. Now, I'm going to do the other two problems kind of out by hand. So hold tight, and I'll get that for you real soon.